We know from the past that we've dealt with nonlinear relationships before when we had to transform them when we were dealing with data. So if you remember data transformations, then you'll remember that we've dealt with nonlinear relationships. Now, in a similar way, we can try and linearize these nonlinear relationships if we know what they are. So remember, we have some nonlinear relationships now that we know exactly what they look like. And they look like this. So we have a parabola, which is this U shape. We have a cubic, which is this shape like this. Remember, it's just like a parabola, but this side here is flipped upside down. We have a hyperbola, and we have a truncus. And again, for the relationship between the truncus and the hyperbola, it's pretty much, it looks like the left-hand side has been flipped upside down. Now, if we can establish that the graph that we have, or the numbers we have, form one of these particular shapes, then we know how to transform the axis. For example, if my relationship forms a parabola, then I know that if I make axes that look like this, with x squared as that variable and y, then my parabola, which when I plotted x against y, which looked like this, when I had x and y, will now become a straight line, and it will look like that. So what I need to do is I need to establish the relationship. And then I need to change my x-axis to suit which relationship it is. So the first thing I do is establish the relationship, and then I transform the x-axis. And then, if I do all that right, I should end up with a straight line. So let's do an example and see how we go. So we're given a relationship here, and we don't know whether it is linear or nonlinear, although considering the subject topic, we can probably assume that it's nonlinear. What we're going to do is we're going to put our values into the calculator, and we're going to see what it looks like. So we're going to end up with a graph that has x and y. So let's put our data points in. 1, 2, 3, 4, 5. Let's make it 5, shall we? Excuse me. And 2.5, 10, 22.5, 40, and 62.5. So here's our data. Now we want to sketch x and y. So what I'll do is I'll just make my graph here, which is going to look something like this. There's x and there's y. And when I make the graph, I'm going to do my xy line with x against y and set that, and then hit the go button. And you can see here I have a non-linear graph, and it looks something like that. Now, the problem is, if I start considering which of my possible relationships this is, I remember my parabola looks like that, and this bit here is similar. So if that's x squared. But also, if I have a cubic, it also looks like that, and this bit here is similar. So, as parts B and C ask, is it an x squared or an x cubed relationship? And we don't know. So what I'm going to do now is I'm going to do part B of plotting the graph against x squared. And I'm going to transform this information exactly the same way as I did when I did my transformation of data. So I'll make a column here that I'll call XS for x squared, and I'll do x hat 2 for x squared, and here is my x squared column. So now for part B, my graph will tell me whether it's an x squared relation when I say I'm going to plot now x squared against y and go. And you can see here, this is a perfectly straight relationship. So when I plot y, and remember this part here is the x squared axis, I get a straight line. And because it's a straight line, I know that the rule of the relationship is going to have something to do with y equals kx squared. So I'm going to write that down because I will be using that for part D. Now for part C, I am asked to plot the graph against x cubed, so let's do that. So I'm going to call this x cubed, which I'll call CU for cubed. And down in my calculate box, I'll do x to the power of 3, and here's my x cubed. And you can see when I sketch my CUs against my y's, I get a nonlinear relationship. So part C has this nonlinear relationship. So it looks like this. So my y and x cubed graph tells me that it is not of the form y equals something x cubed. So now all I need to do is I need to work out this value for k. So let's have a look at how we do that. Now we know that these lines, these points are on my graph. So I can say, well, if my rule that I've established, because of my straight line, the rule is y equals kx squared. So therefore, when I'm looking at my point of, let's imagine 2, 10. So let's look here. Then I know when x equals 2, y equals 10. And if I put that into this equation, I'm going to get y is 10. So 10 equals k times 2 squared. And if 10 equals k times 2 squared, then I can go back to my main screen and I can solve this by saying 10 equals k times 2 squared. Put that into my solve area where I'm solving for k, and I get an answer of k equals 2.5. So now that I know that k equals 2.5, I know my rule is y equals 2.5x squared. So there's that. Now finally, there's a tiny little check that I can do. If you remember all the way back to our previous class, we said a rule of y equals kx squared would have a point of 1 and k. So this line would have a point of 1 and k, and it does because this k value is 2.5.